Hello, welcome to this lesson in AC circuit analysis. We're going to be doing this problem and solving it with mesh currents. The problem simply states find the current I that's labeled here in the drawing. So we'll be using mesh currents. So let's first draw our mesh current reference directions. This guy will circulate clockwise, we'll call it I sub 1. This guy will circulate clockwise, we'll call it I sub 2. And before doing anything, you can realize that we're going to be solving these for these currents. Once we find them, since I1 is circulating in the same direction as I, basically they're equivalent to each other because this guy's down here, there's nothing else down here. So once we find I1, we already know what that current is. So it looks like a simple problem, and honestly it is a simple problem, but just like everything else, there's a couple little things along the way that you have to kind of have to be careful about. It looks a little bit simpler than it is. But once we talk about it, you won't think it's hard because I'll explain everything, hopefully. So what we're going to do is walk around mesh 1 and see what happens. So let's go ahead and do that right now. On the left, we will have the following mesh equation. So the mesh equation is going to be as follows. We're going to walk around this direction. We're going to be going a voltage rise. So this will be negative 400 at an angle of 0 degrees. That's the phasor there. And as we walk through this impedance, it'll be I1 times 5 times 5. And then it'll be I1 times negative J10. For this voltage drop and this voltage drop, and then we're going to get here. Here's where the first problem really pops up in this circuit here, because we don't know what the voltage drop is across this, and it's not an impedance that we really are comfortable with, like a resistor or an inductor or a capacitor, so we can't calculate the voltage drop by Ohm's law. So what do? We have to write down the voltage drop across it as we walk through it, but it's a current source. So even if we knew what V delta was, V delta is defined to be the voltage across the inductor, even if we knew what it was, we